Hello again, grade 12s. Welcome to the last section of your grade 12 syllabus. I'm sure you're very excited to finish. This is one of the sections where you'll be able to score high marks in. So follow along. You can pause the video to take notes. So we have dealt with what we call univariate data in the past. So from grade 8 all the way up to grade 11, we've dealt with univariate data, and this means data that contains one variable. So for example, data about housing prices during the past year or daily temperatures during the past month. And this type of data is graphed on either a bar graph, pie chart, and so on. When we study two variables at the same time, we refer to this as bivariate data. And bivariate data can be represented on a scatter plot. So if we look at the three examples we have here, we have three different scatter plots. We have one where there is a linear or a straight line. You have one that is a quadratic or a parabola, and you have an exponential function. So these are all examples of scatter plots. Just the line that you see there represents or relates to different types of graphs of functions. The scatter plot can be used to draw a line that can best be fitted to the points given so as to approximate points in between or even beyond the data set that you're given. So if we look at our linear scatter plot, we can approximate or find what a value is in between the given data set. So the minimum value here was 18 and the maximum value here was 40. If we're given a value that is, let's say, 23, we can use that using the line, okay? We know the general equation of a straight line, okay, is y equals mx plus c. So if you have that, you can use that and plug in the value 23 to approximate what the corresponding y value is. The x value here would be your age, your y value would be your height. X being the independent variable and height being the dependent variable. Using that, we would call that interpolation. Inter meaning in between or inside the given data set. Since those are your maximum and minimum values, 18 and 40, if you are told to approximate a value that is outside your given data set. So say, for example, they ask you to approximate something that is, say, 50 or someone that is 50 years old. You would want to approximate their age. The point here, 50, is outside your given range. So that would be called extrapolation. You could also be given a y value, okay, and be asked to approximate. Again, it would be either interpolation or extrapolation, depending on whether the value that they ask you or the value that they give you is within the data set that you begin with. For your grade 12 syllabus, we will focus on linear scatter plots. So when we study two variables, we're often trying to find out if there is a link or relationship between the two. If there is a link, then we would say the two variables are correlated. Correlation refers to the relationship between a dependent and independent variable. Correlation values fall between 1 and -1, and we call this the correlation coefficient, and it is represented using the letter R. Scatter diagrams show how a change in one variable affects a change in another variable. The closer R is to either -1 or 1, the stronger the relationship between the variables x and y. If R is positive, the gradient of the line is positive or upward sloping, and if R is negative, then the gradient of the line is negative or downward sloping. In a perfect correlation, all the points lie on a straight line. We're now going to look at the two diagrams we have below. They talk about correlation and correlation coefficient. I would suggest that you pause the video at this point so you can read the finer details in the diagrams. The idea is we want to match the graphs or the scatter plots to the correlation coefficient. So let us look at the first one, the first graph, the one with the strong positive correlation. So as you can see here, again, the points are close together and they almost lie on a straight line. So if you have a strong positive correlation, the R value here for this first one could be R is equal to 0,9. For the second graph, that's a fairly strong correlation, okay? And the correlation value, you can see it's upward sloping, so again, it will be positive, but this time it's slightly weaker, and it's going to be 0,5. The third one, as you can see, that's a perfect positive correlation, and there your R would be equal to 1. The points lie on a straight line. If you were to draw your line, and this we call the line of best fit, you can see that the line or the points fall on the line. The fourth graph shows no correlation. So the points there and the relationship between x and y, there is no relationship, so the R is equal to 0. For a strong negative correlation, the graph is downward sloping, therefore you will have an R value that is negative. So if it's a strong negative correlation, that would be approximately negative 0,9. Fairly strong negative correlation, that would be approximately R is equal to negative 0,5. And a perfect negative correlation, R is equal to negative 1. Again, drawing your line of best fit for these, the closer those points are to your line of best fit. Sorry, this one that I just drew isn't exactly straight, but you can see that with this perfect negative correlation, all the points fall approximately on the line.